This is the tutorial video for Monday, May 10th. Last week we talked about motion and various formulas that we calculate different aspects of motion. This week we're going to be talking about forms of energy. Two in particular we're going to take a focus on. So we got to think first, what is energy? And you can find a bunch of different definitions of energy, but ultimately the easiest energy definition is the ability to do work, okay? The ability to create change. Energy is something that can be measured. It's a scalar quantity because it's not in a direction, it's just an amount. Energy is measured in joules. We've used joules a bit at this point. You used it in grade 8. You did work equals a force times a distance. We're gonna look or incorporate that formula a bit in some of the work we're doing this week. There are a number of different forms of energy. Energy, we remember, can't be created nor destroyed. It can be only changed. When we think of the major classifications of energy, or the major two groups, those two are potential energy, and which is stored energy, and kinetic energy, which is the energy of movement. And then it kind of breaks down into smaller branches of each group. We see thermal energy, the energy of heat; mechanical energy, the energy of objects in motion. So that includes sound energy, electrical and magnetic energy. We see chemical energy, the fuel energy stored in food, and fuel. Elastic energy, the energy stored in a stretched object. Nuclear energy, the energy stored in particles. And gravitational energy, the energy stored in an object that is held above the Earth's surface. That's going to be the one we dig into today. So there are a number of different types of potential energy. There's chemical potential energy, again, which is the energy that's stored in, say, the food we eat. It's broken down, and the chemical reaction, of course, takes place in the mitochondria, which gives our cells energy. Anything that's elastic has energy. When you stretch an elastic or when you compress a spring, it wants to go back to its original state. Finally, when we lift something above the earth, we give it potential energy because when that thing gets dropped, say a glass from the counter in your kitchen, that potential energy gets transformed into the energy of movement, and then gets transformed into the physical contact with the ground, which shatters the glass. We have a pretty basic formula to calculate gravitational potential energy, and that is the amount of energy, potential energy due to gravity, is equal to the mass of the object times the rate that gravity accelerates objects to the Earth, which is here, 9.81 meters per second squared, and times the height of the object. So one of these things you'll always have on Earth, it for our purposes will remain the same, 9.81 meters per second squared. That's your g. And then the mass of the object and the height of the object multiplied by the acceleration of gravity will give you the amount of energy in joules. So a couple examples to go through. A reminder, you're welcome to pause this video and try the examples yourself. If I lift my 18.1 kilogram bike 1.9 meters above the floor, how much energy does it have now? Well, potential energy, I just usually write EP for my potential energy. Potential energy is equal to mass times gravity times the height of the object. The mass of the object is 18.1 kilograms. The acceleration due to gravity is 9.81 meters per second squared. And then the height of the object is 1.9 meters. Please remember that if you ever get a question that's not in meters, we need it in meters because it is the same as the units in the acceleration due to gravity. Same with kilograms. You need to have kilograms. When I multiply these numbers together, 18.1 times 9.81 times 1.9, do it again, 118. The number that I get is 337.365. We just want to look to the least amount of significant digits. In this case, it's the least is 2 in the 1.9. So I need to make my thing go to 3.3, 2 digits. The next number I have is a 7, so I actually have to round up to 3.4. And that's going to be times 10 to the power of however many times I need to move this decimal place to the left, once, twice. So it's 3.4 times 10 to the power of 2 joules. Work involves a change in energy. So when you lift this bike up, 1.9 meters, how much work did you do? Well, the change in energy was the work you did to lift the bike up. So the change in energy is just 3.4 times 10 to the power of 2 joules. So of course the more difficult questions are questions that ask you for the mass of an object, and you'd be given the height. Given the height and the potential energy. Alternatively, you could be asked for the height of the object. Here's an example. In 1993, Cuban athlete Javier Sotomayor set the world record for the high jump. The gravitational potential energy associated with the jump was 1,970 joules. His mass was 82 kilograms. How high did he jump? So you can do this two ways. You can just rearrange the formula. You could rearrange the formula to isolate what you're looking for. They've given us the mass. They've given us the mass. They've given us the potential energy. They're asking for the height. So I can rearrange this formula to get height by itself. These three now, m times g times h, they're all being multiplied together. So to get rid of it, you have to do the opposite. I need to divide by mass. I need to divide by gravity. I do the same thing to both sides. Because these cross each other out, it will be potential energy divided by mass divided by gravity will equal height. Okay, so I'll just rewrite out the formula as I've rearranged it. Potential energy divided by mass divided by gravity will equal height. Potential energy is 1970 joules. Mass is 82 kilograms. Gravity is 9.81 meters per second squared. When we do that calculation, we get 2.448. Let's look to the least amount of significant digits would be 82.0 kilograms, so that's 3. So we're going to round to the third digit, 2.4, round up to 5. What are we asked? We're asked the height. What units is the height in? The same as in our acceleration due to gravity, meters. So here is our answer there. So for our next example, I had to make a little edit on the version I had, and this is what you will see just typed on your notes. An object has a gravitational potential energy of 41,772.5 joules, and is 2.74 meters off of the ground. What is the object's mass? So same as before, we just need to manipulate our potential energy due to gravity formula, which is mass times gravity times height. Well, in this case, we are being asked to find mass, so we divide both sides by gravity and height. Why we do that is because gravity divided by gravity, height divided by height cancel each other out, and that will allow us to find mass. So that potential energy, again, is 41,772.5 joules. We know that gravity is 9.81 meters per second squared. We know that the height is 2.74 meters. When we do that calculation, we get that mass is equal to 1,554.07 grams or kilograms. We have to look to, if we're doing it completely correct, we have 3 significant digits in our question, so we would need to move it over to just have 3 digits. So that would look like this: 1.55, 4 rounds down, times 10 to the power of, I would need to move this over once, twice, 3 times, 10 to the power of 3 kilograms. All right, for the last example, we are going to connect gravitational potential energy with work and with a change in energy. So the example we're given, we have to calculate the amount of work done in lifting a 2.2 kilogram object from a height of 1 meter to 2.6 meters. So how we have to find that change in energy is we have to take the amount of potential energy that the object had at 1 meters, find out the amount at 2.6 meters, and then find the difference between the two. That difference between the two will be the change of energy. So you're welcome to pause the video and try this on your own. The potential energy of the object at its new height is 2.2 kilograms, the mass, times 9.81 meters per second squared, gravity, times the height of the object, which is 2.6 meters. When we do that calculation, 2.2 times 9.81 times 2.6, we end up getting 56.1132. We'll keep those digits and do our rounding at the end. The amount of energy at the original height, the mass would have stayed the same, 2.2 kilograms. Gravity, or the acceleration due to gravity, stays the same, but my height instead of 2.6 is 1. So really I'm just multiplying 2.2 times 9.81. I get the number 21.582. So the amount of energy that changed when I lifted the object, the amount of work that I did, would be the original, the final height, 56, and the energy there, 56.1132, subtract the original height's energy, 21.582. So the change in energy would be, we added 34.5312. We look to our question, 3 significant digits is our least amount. So we have to round down to the 3rd digit. The 4th digit is a 3, so I just erase it. Finally, this is in joules. This is how much energy, potential energy due to gravity, was added when the object was lifted. So a change in energy is equal to the amount of work that's done. They're both in joules. Okay, so the amount of work that was done was 34.5 joules. we can use that to find the force that was required to do the lifting. We know that work is equal to force times distance. If we know the work, 34.5 joules, and we know the distance that it was lifted, which is the difference between 1 and 2.6, which is 1.6, we can use that to find out the force that it took to lift it. If force times distance is equal to work, then I just need to divide both sides by the distance to isolate the force. When I do that, I take 34.5 divided by 1.6, and my force that was required was 21.56 newtons. We'd probably just keep it consistent with the significant digits from the previous part of the example, so that would round up to 21.6. The final question, I'm realizing we gave it to you. The potential energy that the system has now would be the potential energy at the height of the object now, which is 56.1 joules. So that's all for the video lesson. In your notes, if you click here, there are practice problems with answers that you're encouraged to take a look at.